Good morning. Welcome to Ramblings with Joe. Today I thought I'd try something a little bit different. Yesterday my podcast was kind of a flop because I wasn't as prepared as I thought I was to talk about total entropy and the black hole situation. Not the black hole, the expansion of the universe. So today I thought that we'd talk with Grok. Good morning, Grok. Welcome to the podcast.
Good morning. Thanks for having me on Ramblings with Joe. I'm excited to be here. No worries about yesterday's flop. We're going to make today's episode a cosmic hit. Total entropy and the universe's expansion are juicy topics, and I'm ready to dive in with you. So, where do you want to start? Entropy's chaos, the universe stretching out,
Well,
or something else
yesterday we
entirely?
sort of had a problem with the length of your responses, I think, and it was so involved that I just didn't have time to talk about it. So today I'm hoping that you can keep your responses very short.
Got it. I'll keep things short and sweet today. What specific part about total entropy or the universe's expansion do you want to dive into?
Well, my original question was, is there a place in the universe that has complete stillness?
No, complete stillness doesn't exist anywhere in the universe. Even in the vast emptiness of space, particles are buzzing with quantum fluctuations, and everything's affected by gravity, radiation, or cosmic expansion. The closest you get is maybe a distant void with near zero energy, but even there, space-time itself is stretching due to the universe's expansion. Want me to dig into that quantum stuff or the expansion part?
Let's start with the Big Bang because it was my impression that the Big Bang had a central starting point. And for some reason, I recall the science teachers in school telling me that the Big Bang started from a point as small as a pin. And as you told me on Sunday, that's not actually the case.
Right. Let's clear that up. The Big Bang wasn't an explosion from a single pinpoint in space, like a firework. Instead, it was the rapid expansion of all space-time from an incredibly hot, dense state. Think of it as everywhere starting super tiny, not just one spot. The pin idea comes from simplifying how the universe was compressed, but it's more like the whole universe was that pin, expanding all at once. No central point, just everything stretching everywhere. Want me to explain how that ties to entropy, or keep it on the Big Bang?
Let's stay central to the Big Bang for now. Also, if you wouldn't mind, don't end your statements with a question.
Got it. I'll keep it straightforward. The Big Bang started about 13.8 billion years ago, when all of space-time was compressed into an incredibly hot, dense state. Not a single point, but the entire universe in a super tiny, uniform state. It expanded rapidly, cooling as it went, forming particles, then atoms, stars, and galaxies. There's no center since space-time itself stretched everywhere at once, like the surface of a balloon inflating, not a bomb going off.
Okay, so we're getting to the problem that I had with the expansion situation. When you use the word expansion, that usually kind of intimates that something is being blown out, not blown up, but kind of expanded into something. And I had a problem with what into was. And I understand you're saying that there wasn't anything there, but does science have a name for that area or that non-area that came before the Big Bang?
Science doesn't have a name for what came before the Big Bang, because time and space as we know them began with the Big Bang itself. It's not that the universe expanded into some pre-existing non-area or empty space. The expansion created space itself. Think of it like the universe making its own room as it grows. No external void or container needed. We hit a wall here, since our physics can't yet describe before the Big Bang, as time started there. It's a cosmic blank spot in our understanding.
That cosmic blank spot, does that extend to what is beyond the universe as we know it now?
Yes, the cosmic blank spot extends to what's beyond the universe as we know it now, because our understanding of beyond is limited by the observable universe, the part we can see about 93 billion light years across, due to light's travel time since the Big Bang. Beyond that, space might keep expanding forever, or there could be other regions we can't detect, but we have no data or name for anything outside our observable bubble. It's just more of that cosmic unknown, like the pre-Big Bang state.
That's interesting to me because what I'm hearing is that there's a non-existence beyond the universe, and that sort of non-existence could be anything.
Exactly, you've got it. That non-existence beyond our universe could indeed be anything, or nothing at all, since we lack any way to observe or measure it. The observable universe is all we can study, and what lies beyond, if anything, is purely speculative. It's like trying to describe a room you can't see into. It might not even exist as a room. Science just shrugs and says, we don't know yet.
Are there any suppositions as to what is beyond the universe?
Yes, there are theories. Some cosmologists suggest a multiverse, where our universe is just one of many bubbles with different physics. Others propose an infinite universe that just keeps going, unobservable to us due to light's finite speed. There's also the idea of a true void, nothingness with no space or time. These are all speculative, though, since we can't test or observe beyond our universe's light cone. It's educated guesswork at best.
On Sunday, you told me that the universe, that all, how did you say it, all of the galaxies or objects are always moving away from each other. Can you clarify that for me?
Sure, I can clarify that. The universe is expanding, which means that, on large scales, galaxies are moving away from each other. It's not because they're zooming through space, but because the space-time between them is stretching, like how dots on an inflating balloon get farther apart. The farther a galaxy is from us, the faster it appears to move away, as seen in redshifted light. This is true for most galaxies, except for nearby ones where gravity can pull them together, like our Milky Way and Andromeda, which are actually on a collision course.
So the galaxies that are moving away from each other on that large scale, is there a point where most of them are moving away from?
No, there isn't a specific point most galaxies are moving away from. The expansion is happening everywhere in the universe simultaneously. There's no center. Every galaxy sees all others, outside local groups bound by gravity, moving away, as if each is the center of the expansion. It's like every dot on the surface of an inflating balloon moving away from every other dot, with no dot being the central point of the balloon's surface. The whole universe is stretching uniformly on large scales.
Inside that balloon that is stretching with the dots on it, is there more dots inside there? More galaxies within the balloon that are also moving away from each other?
Yes, inside that balloon analogy, there are indeed more galaxies, more dots, within the expanding space of the universe, and they're also moving away from each other on large scales. The balloon's surface is just a 2D analogy for our 3D universe. Every point in the universe, whether near or far, is part of the same stretching spacetime. Galaxies throughout the entire volume of the universe, not just on some surface, are generally receding from each other due to this expansion, except where local gravity, like in galaxy clusters, holds things together.
So the galaxies that are moving away from each other, let's say there's 8 galaxies, and all 8 galaxies are moving away from each other. Wouldn't that imply that there's a center point between those 8 galaxies?
No, it wouldn't imply a center point between those 8 galaxies. In the expanding universe, there's no single spot they're all moving away from. Picture those 8 galaxies as dots on a balloon surface inflating. Each dot sees all others moving away as the space between them stretches, but there's no center dot or point in the middle of the balloon surface where the expansion started. In the real universe, every galaxy's like a vantage point where all others, on large scales, appear to recede, with no central location in 3D space. It's the uniform stretching of spacetime itself, not motion away from one spot.
The analogy of a balloon is a really bad analogy, like the pinpoint explosion, Big Bang thing. The analogy of the balloon has a center point because balloons have center points. Every globe has a center point. Is there a better analogy that scientists and teachers can use to teach us lay people?
Fair point. The balloon analogy can be confusing because it suggests a center, but there isn't one in the universe's expansion. A better analogy is dough rising with raisins in it. As the dough expands, Every raisin moves away from every other raisin, and no matter which raisin you're on, it looks like the others are receding from you. There's no center point in the dough, it's all expanding uniformly. This captures how galaxies move apart as spacetime stretches, without implying a central spot, like a balloon's core.
It's very difficult to wrap my mind around if everything is moving away from everything, that there's not some point somewhere that is not expanding, that there must be a point somewhere where there's, I mean, if everything's moving away from each other, this is what got me on Sunday. On Sunday, this is what really confused me. Everything's moving away from each other, but there's no center point. So if you take three galaxies and they're all moving away from each other, let's say these two galaxies are moving away at, whatever light speed, not light speed, but whatever speed they're moving away from each other, and then this one over here is moving away, somewhere in here there is a point of equidistance. Is that not right?
No, that's not quite right. Even with three galaxies moving away from each other due to the universe's expansion, there isn't a fixed point of equidistance that acts like a center. Imagine those galaxies as raisins in that rising dough I mentioned. As the dough expands, the space between all raisins stretches uniformly, so each galaxy sees the others moving away from it, but there's no special spot in the dough where you'd say, here's the center. The equidistant point you're picturing shifts depending on which galaxy's perspective you take, because the expansion is happening everywhere in spacetime, not from one fixed location. It's the space itself stretching, not galaxies moving away from a common middle point. I know it's mind-bending. There's no single spot in the universe you can pin as the center of expansion.
So it's not the galaxies moving away from each other, it's time, space, forcing them apart?
Exactly. It's spacetime itself stretching that forces the galaxies apart, not the galaxies moving through space on their own. Think of spacetime like the dough expanding, carrying the galaxies, those raisins, along with it. The farther apart two galaxies are, the more spacetime there is to stretch between them, so they seem to move apart faster. It's the fabric of the universe doing the work, not the galaxies zooming away from each other.
So not inertia, but rather being forced apart by space-time.
Right, it's not inertia. They're not coasting apart from some initial push. It's spacetime itself expanding, like the dough rising, that carries the galaxies farther apart. The stretching of spacetime itself is what drives the separation, not any force or momentum the galaxies have on their own.
It seems like I read somewhere that the speed of the galaxies separating from each other is increasing. Is that right?
Yes, that's correct. The expansion of the universe is accelerating, meaning galaxies are moving away from each other faster over time. This is driven by dark energy, a mysterious force causing spacetime to stretch more quickly now than it did billions of years ago, as observed through distant supernovae and cosmic background radiation.
All right. Well, I can't say that I completely understand everything that you've told me today because I do live within this universe. So maybe that's part of my problem. I can't wrap my mind around nothingness or lack of existence beyond the universe. Also, what the dark matter, has that been confirmed? Do we know for a fact that there is dark matter and dark energy?
I get how tricky it can be to grasp concepts beyond what we experience. It's totally normal to struggle with the idea of nothingness outside the universe. As for dark matter and dark energy, we don't have direct proof, like holding them in a lab, but they're strongly supported by evidence. Dark matter, about 27% of the universe's mass, is inferred from its gravitational effects, like how galaxies hold together and spin faster than visible matter alone can explain. Dark energy, roughly 68%, is supported by observations of the universe's accelerating expansion, like the speeding up of distant galaxies we just talked about. These aren't guesses. They're based on solid data from things like galaxy rotation curves, gravitational lensing, and cosmic microwave background studies. But we still don't know their exact nature, so the search continues.
Interesting. What about the area beyond the universe? Could that be dark matter?
No, the area beyond our universe, if it even exists, wouldn't be dark matter. Dark matter exists within our universe, interacting gravitationally with galaxies and clusters, holding them together. Beyond the observable universe, we can't say what's there, as it's outside our ability to measure. It could be more of the same universe, different universes in a multiverse, or just undefined nothingness. But dark matter is specifically a component inside our universe, not something filling a hypothetical outside.
It really bothers me that we're not giving a name to that area outside our universe. It makes it very difficult to have a conversation with anybody about the universe in general because we are kind of a self contained, for lack of a better word, bubble. Why hasn't science given that area or that non existence a name?
I hear you. It can feel frustrating to talk about something without a label. Science hasn't named that area or non existence beyond our universe because we have no data or way to study it, so it remains undefined. Calling it anything might imply we know more than we do, and scientists are cautious about that. The universe is self contained, like you said, not sitting in a bigger bubble we can measure. Some toss around terms like multiverse for speculative regions beyond, but that's not a confirmed place. It's a hypothesis. Without evidence, naming it could mislead, so it's left as a cosmic question mark.
That's a huge question mark. That's a gigantic question mark. That's a question mark beyond human comprehension. I also don't understand still why they can't name it. I mean, we don't know everything that we do that's possible to know about dark matter and dark energy, and we have given it a name. It's an ambiguous name, albeit, but it is a name. And I guess that we just continue to call that area outside the universe.
I get why that huge question mark bugs you. It's hard to wrap your head around the unknown. Scientists name dark matter and dark energy because we see their effects in the universe, like gravity or accelerating expansion, so they're placeholders for measurable phenomena. The area outside the universe, though, has no observable effects or data we can point to. It's not even clear if outside exists as a concept. Naming it might suggest it's a thing we can study, which we can't, so it's left as the beyond, or just not addressed. It's frustrating, but it's why we stick to calling it the unknown, rather than pinning a name like we did with dark matter.
Okay, so as the universe expands, we're going to move on to entropy now. As the universe expands, the universe is cooling, and eventually it will experience something called heat death. Do I have that right?
Yes, you've got it right. As the universe expands, it cools because the same amount of energy is spread over a larger volume. Over an immense timescale, this expansion leads toward a state of maximum entropy, called the heat death, where the universe becomes a cold, uniform soup with no usable energy left. Everything's just evenly spread out and still.
But it's not actually going to be complete entropy because there will always be some movement, correct?
No, in the heat death scenario, complete entropy is theoretically reached. Movement would essentially stop. All usable energy would be evenly spread out, leaving no gradients or differences to drive any processes, like motion or chemical reactions. Quantum fluctuations might still exist at an incredibly tiny scale, but for all practical purposes, the universe would be at maximum entropy with no significant movement or activity left.
So because of that, what did you call it, quantum movement, there will be no place still in the universe that is perfectly still.
Right. Because of quantum fluctuations, there won't be any place in the universe that's perfectly still, even in the heat death scenario. These tiny, random quantum jitters, caused by the uncertainty principle, mean particles are always wiggling at some level, no matter how cold or uniform the universe gets. So, absolute stillness with zero motion is impossible due to these fundamental quantum effects.
Is there another theory other than heat death that exists?
Yes, there's the Big Bounce theory, where instead of heat death, the universe collapses and rebounds in a new Big Bang, cycling indefinitely. Another is the Big Rip, where dark energy accelerates expansion so much it tears galaxies, stars, and even atoms apart. Both are less likely than heat death based on current data, which favors continued expansion toward maximum entropy.
So you called it maximum entropy. That's not total entropy because of quantum movement.
Actually, maximum entropy still means total entropy in cosmological terms. It's the ultimate state where no more energy gradients exist for work or change, like in the heat death scenario. Quantum fluctuations don't prevent this. They're just tiny, random jitters that don't create usable energy or disrupt the uniform, disordered state. So, maximum entropy is effectively total entropy, with no significant organized motion left, despite those quantum wiggles.
Have we scheduled when this maximum entropy will happen?
No exact schedule, but estimates suggest maximum entropy, or heat death, won't happen for at least 10 to the power of 100 years, a mind-bogglingly long time, often called a Google years. This comes from models of the universe's expansion and energy dissipation, assuming dark energy keeps driving things apart. It's so far off, stars and black holes will long be gone before it's reached.
How many years before this happens?
It's estimated to happen in about 10 to the power of 100 years, or a Google years. That's a 1 followed by 100 zeros. Starting from now, roughly 13.8 billion years since the Big Bang, it's an unimaginably long time, far beyond when stars and black holes will have burned out or evaporated.
So this is just for the audience to understand. This is nothing that we're ever going to see in our lifetimes, and probably not the lifetime of the Earth. When is the sun going to supernova?
No, this maximum entropy won't happen in our lifetimes, or even Earth's. Definitely not. The sun won't go supernova, though, because it's not massive enough. In about 5 billion years, it will swell into a red giant, possibly engulfing Earth, then shed its outer layers and become a white dwarf. That's the sun's fate, not a supernova, which only happens with much bigger stars.
Excellent. It's good to know that our sun's not going to be a supernova. I was worried about next week.
No worries. We've got at least 5 billion years before the sun turns into a red giant. So next week's safe. Glad we cleared that up. Any other cosmic concerns you want to tackle for the Ramblings with Joe audience?
No, I think that's it for today as far as the cosmic goes. What is the most popular topic that Grok is talking about? A longish pause. No response. So at this point, Grok seems to have locked up. Grok, are you there? Yeah, it's having connection issues. So that's why I was so confused yesterday. As you can hear, Grok has helped out quite a bit today, clarifying. I don't know how much of that I will hang on to, but it was a very interesting subject. Grok, I'd like to thank you for helping clear that up and putting an appearance in on the podcast today.
Thanks for having me on Ramblings with Joe. I'm glad I could help clear up the cosmic confusion. Hope some of it sticks. Always a blast diving into the universe's mysteries with you. Come back anytime for more.
All right, I'm out of here. So that was Grok.
Catch you later.
And I find it a useful tool, but it's still a tool. The ability to talk to Grok in a normal tone, as you just heard, it's kind of a little bit fettered by the ability of it to have a non-disjointed conversation. It usually will, there's always a little gap in the conversation that it has. It was still listening. I had to close it. I'm sorry about the audio quality. I'm lacking one cord to do a direct connection and use the better microphones. So today I'm using my lapel mics, but maybe I can get that going on here one day if I ever have Grok back on. I'm curious as to your thoughts about Grok and actually having Grok as a guest. That's a step closer to recognizing Grok as an entity unto itself. That was kind of a long podcast. And I think I garnered a little bit more knowledge about the scientific theories about how the universe came into being. I know that a large part of my audience, at least half of you, which means one of you, probably disagrees with that particular theory. And science is theories. Everything in science is theories. All we have are accepted science, which means it's accepted for now. Eventually, it can be changed. Eventually, science can, if it's proven wrong, then it's proven wrong. There's nothing horrendously personal about it. The problem that science has is the inability of people who have learned accepted science to accept change in that science. There are people who fight against that. Some of it is because of personal reasons. For instance, if a scientist has discovered something and it becomes established science, and that's what the general consensus of scientists worldwide believe, and then someone comes up with a different theory and shows this theory has more validity than yours. We're human beings, and scientists are human beings, and they may take offense to them being called wrong. I've definitely learned that over the past 5 years. People do not like to be told they're wrong. And as you just heard, Grok has told me several times today that I'm wrong. And I'll continue to be wrong, because until you accept the idea that you can be wrong, you don't grow or learn. So that was an interesting interaction. One of the things that I noticed during the Grok interaction was I had the ability to drink a little bit of coffee while she was talking, and that was kind of nice. I think I need a co-host with their own cup of coffee. That would be awesome. Which one of you two want to be my co-host? We'll call it Ramblings with Joe and that big expanse on the outside of our universe. Yeah, I suppose that, I don't think that a fish, a water-bound fish, can comprehend what's outside of the water. Well, number one, I don't think that fish are cognitive. But at that level, I don't know what's outside the universe. Nobody does, obviously, and they don't want to give it a name other than at one point Grok called it the beyond, and that was in quotes. So I think that maybe that's what scientists call that area outside of the universe. At any rate, I got to get ready for work. I still got to make a living, because neither one of you want to give me a buttload of money from my audience, either one of you. I had a good time talking to Grok again. It's Grok. I think what Grok does is kind of adheres to your level of intelligence, so that it kind of makes you feel smart. Even when you're as dumb as I am, it kind of makes you feel smart. Like, oh, okay, I get that. And then it'll explain it to you. And it's not talking down to you. And I would imagine if a scientist started talking to Grok, well, number one, I told Grok to keep it short, which, look, when I had that conversation on Sunday with it, these responses were 2-3 pages long. And I would sit and read, and then I'd ask my next question. This was a better way to do things for a podcast, to have Grok do short answers. But I think Grok kind of adjusts its level to your intelligence. So maybe a scientist would be, way up there, whereas I'm down here just talking to Grok at my level, and my level of knowledge and what I can figure out. Maybe there's an algorithm built into it that teaches it to talk to you on your level, for lack of a better word. We all have different intelligence levels. There are so many people smarter than me. I'm not being condescending to people who are less smart than me. I'm not being worshiping those people who are more smart than me. But I recognize that, and it's not a problem for me. That's why we have experts in the world. I would not want a scientist to jump in an 18-wheeler and take a load up the road. He's going to kill somebody if he's never driven a truck before. That doesn't mean he can't learn to drive a truck. It just means he doesn't have that knowledge. I I don't have the knowledge of a scientist. So it's very interesting for me to ask those questions. And I hope that bringing Grok on didn't irritate either one of you today. I don't know how many people listen to my podcast. I look at the stats maybe once a month. It's not anything that's huge. I've got to be the smallest podcast on the internet. Mostly I'm just talking to myself in the morning. I've got about 40 minutes to get ready for work. This is not my normal cup. My normal cup's in the dishwasher. We don't have a full load yet, and I didn't feel like washing it. I do like this cup. I wish the handle was bigger. It's not huge. I can only get 2 fingers in there comfortably. I suppose I could push 3. Oh, look, I can get 4. It's not good. But this is comfortable, and but I drank all of my cream, so now I'm drinking black coffee, and I'm not used to that. But actually, this coffee, I think I will continue to drink black. Sorry for the noise. Yes, I think I'll have this coffee black. It is definitely better. It never occurred to me to do that. Welcome to the rambling part of Rambling with Joe. I'm just going to go on forever. It never occurred to me to adjust the creamer. Not cream, half and half is what I drink. It never occurred to me to adjust the half and half for this cup of coffee. But that is what I need to do for this particular brand of coffee. And if you do like molasses flavored coffee, I would encourage you to get this. This is very good coffee. It's just not my cup of, I keep wanting to say my cup of tea, but it's not my cup of coffee. But it is good. Anyway, it is Thursday. No, it is not. It is Wednesday. It is Wednesday. And we are halfway through the week. I hope that you have a fantastic second half of your week. And I hope you find peace, love, and dream. And I'll see you next time. Ciao.